So we take the data that we put together on the graph the other day. This is what I had on paper. This is the beginning of the lesson's information, eyeballing a line of fit. And what I'm doing is I'm using this example to go through the whole 9 yards of putting together a paper graph, fitting a line to a paper graph, and then doing a regression in the calculator, which essentially is going to do the same thing. So you may wish to pause, may wish to write some things down, but I'm going to fly through this. So this is the year versus the life expectancy. And we've got 1930 through 2020. And this data comes off of page 368, if you don't recall from yesterday. So now, how do you take this and put it onto a graphing calculator? So grab your graphing calculator and grab your data points and information. So here's what we're doing. We're doing a line of best fit, which is a regression line. So I got a bunch of keystrokes up here. The first thing that we have to do is we got to work on this side over here, the right side of the board. And what we're going to do is we're going to take our data from the expected life, or the expected age, life expectancy, and we're going to fit it into an appropriate window as data, simply data points. So we have an x minimum, well, we might make it at 0 and an x max at 100. So what that's saying is that at year 0 on our graph here, that's going to be the same as 1930. So 0 is going to be equal to 1930. And then every mark afterwards, 10, 20, 30, 40, etc., is going to be that many years after 1930. So if this is 10 and this is 20, that 10 would make this 1940, make this 1950. Because if we just put 1930 into our graph, it's just going to be this big, huge, wide graph that's not very effective to use. So get into changing your window size. In order to change the window size, we're going to go to Window to begin with. So we're going to go to Window, and mine looks something like this right here. I'm not sure if I can make this come up. I can't. This doesn't always work so good, but the numbers are up here on the board. You're going to make your x minimum 0, your x max 100, your x SCL, which is the scale, that's the tick marks, is 10. Y minimum, start at 55, because the paper graph we started at 55 instead of 0 years. Life expectancy was never down at 0, or we'd never be here. So Y minimum 55, Y max is 100, at the Y scale is every 5 years for ease as we go up. So it's going to go 55 to 100. Then what we need to do is we need to take all of our data points and enter them into the graphing calculator. And we do that by following these keys here, stat, edit. And what that will do is that will take us to L1, which is list number 1, and L number 2. That's what we're going to work with. So when I do stat, and then I do edit, edit is across the top. Ooh, maybe that might be working a little bit, stat and edit. When I hit enter, I'm going to have all my lists, L1, L2, 3, 4, etc. Now, if you were to have data in L1 and L2 already, all you have to do is use these arrows, move up, highlight L1, hit clear, hit enter, and the whole thing clears. You don't have to do them one by one. Same thing with each of the lists. So get them cleared, put in all your years after 1930. So I went 0 to 100, and then all your life expectancy ages. Get all of those in there. Before you do, hit pause, get them in, come back. Okay, now you're back. Hopefully everything's in there. So we have to be able to plot this onto the window that we created. And we do that through stat plot. So that's the second y equals key. You go to second, stat plot. And then it'll say stat plots. And they'll have a whole bunch of them listed here. And what you want to do is you want to probably start with the first one, and if it says on, you're on and you're good to go. But if it doesn't, if it says off, or if you have to change anything with it, you just hit the enter key. And when you hit the enter key, it'll lay out a whole bunch of information here. Darn. I don't know why this is so tough. Ooh, there we go. Ooh, yeah, it lays out a whole bunch of information there. And that information, we want the on blinking We want the x to be L1. We want the y list to be L2. The type of graph is the first one, which is a scatter plot, not bar graphs or anything like that. And then the type of marking, you can pick whatever you want. I've got tiny little dots. You can have the squares. You can have the pluses. Okay, then once you do that, all you do is hit graph. And you should get a graph. Oh, mine's got all kinds of other functions in here, sorry. You should get a graph of a bunch of dots. Your dots should go all the way across like this. All right, now, that's a scatter plot. And what you need to be able to do is have a fitted line that goes through that. But you're not going to do that by hand. You're going to let the graphing calculator do the work, and that's called a regression. So creating a line of best fit by creating a regression line or doing a linear regression, linear for a linear function because this is a function that gives you a straight line. These are the steps that you go through. You go to stack in the middle, and then you move over to calc, and then you can either hit the number 8 or you can scroll down to linear regression a plus bx. Or you can go to number 4, which might be a little bit more familiar, I think they go to 4. That one's ax plus b. So that puts it in the form that we're used to using, the variables that we are used to using. So you hit enter, and it's going to say x list, hopefully L1, L2, and y list L2. If it doesn't say that, if it doesn't say x list L1 and y list L2, you have to change that. And you would change that with the second key and then the numbers down here. You can see where L1, L2, etc. are. It should come up L1, L2. So all you do is you go all the way down here to calculate on the very bottom, scroll down, hit enter, and it kicks out the numbers. And these are the numbers that I got right here. So you got your slope, and you got the slope is in the variable A, and then the y-intercept is the variable b. Now there's a lot of place values. You don't need so many. I think what we should do is we should write this thing in the form of y equals ax plus b. And I'm going to choose to go 0.21. I'm going to round that off to the nearest hundredth for the slope, x plus, and then the b value is going to be 62. I'm going to go to 0.04. That might be too many, though. I'm going to think back. If we look at our list, all of those ages come to the nearest tenth. So all we can do is go to the nearest tenth. We can only use 3 values. And then this rate of change here, maybe we can really only use 0.2, but I think we can get away with 0.21. It would give us a little bit nicer looking graph. So now you have a function, and you're going to go into y equals. And in y equals, you're going to enter that function. So go to y equals and enter 0.21x plus the y-intercept 62 and hit graph. And then what you're going to get is you're going to get a line that shoots through all your data points, and that's a regression line. And that is an extremely accurate calculation of what these data points would represent if they were indeed a true linear function. So we're going to go over that a little bit more on Monday, and then we're going to have work time in class on Monday and do some examples and such. But that's the guts of it. That's what gets you through this lesson.